Hello, my name is Stephanie Anthony, editor at New Food magazine. At this year's RAFA exhibition, we hosted a roundtable discussion, sponsored by SciEx, on the topic of contaminants and novel approaches in food analysis. Featuring a group of key individuals from the industry, the main themes discussed were key changes within the next 10 years, how data handling is influencing future trends in analytical protocols, the influence of legislation on the industry, what changes are expected to be implemented to the scoring of an assay, limitations of current technology, and the key challenges facing food chemists today.
If we're looking at 10 years down the line, what we'll see is the speed and the sensitivity increase. I believe there will be a geographical divide between the industrialized countries and those ones which are not.
Actually, I assume that the different groups of contaminants will be combined in one analysis. Until now you have mycotoxin, pesticides, but maybe in future there is no reason why not to do that. We will combine these analytical approaches into one.
I think industry will be needing to develop smart systems, and I think the emphasis will be on systems rather than analysis. We always talk about analysis, but it's got to be much more broader range based on untargeted type technology that can give industry a more intelligent quality assurance.
I still see a lot of the work being done in the laboratory before going online. Do you see any shift in laboratories going more online, given the technologies that exist today?
And you'll have a big, as I say, spectrum of types of analysis, and it'd be interesting to see where the sort of experts fit in and how industry and the regulators can cope with this noise that they're going to get, some of which they can use and some of it which will be diverting. So it's going to be really interesting to see how what we would hope would be the core expertise links in with that whole spectrum of data.
When we're looking at the non-target approach, there is no legislation in place. It's just the desire of the food industry to deliver high-quality products and reduce the risk.
This is quite difficult because there are not such easy rules like for target analysis.
You have to point out actually that in order to come up with legislation you need a scientific opinion, let's say from the European Food Safety Authority, and that is actually based on sound survey data. A survey has to be initiated and then the whole process starts from scratch. Then, well, we are talking years here. Yeah.
I'm not sure chemistry is the right word anymore, because we can do proteomics using mass spectrometry. So are we chemists, or are we molecular biologists, or protein chemists, or whatever? So that's one of the things, that interfacing chemistry and biology is going to be, and informatics. Those three things, and I'm not sure those people exist. We have bioinformatics at FERA, and we have chemists, and we have molecular biologists. What we really need is an amalgam of the three.
And we still need education on the university level. So what I am facing is often that there is cut down of funding in teaching, university teaching, and that is the wrong way, I would say, because we need the education, and that's the bottleneck. So politicians have to be called upon putting more money in education.
What I see also is the fact that the food chemist itself needed to speak, for example, with the marketing director to buy the new instrument, need to speak with the authority to explain the results, need to speak with the public because there is an incident and alert, so you need to have a very broad kind of communication skills depending on the kind of category you have to face.
I think, as you said, you have two different groups where you're looking at implementation. You have the university, where you have maybe a shortness of funding, and then you have the food testing labs, so the labs within food production companies that do the testing, where you're facing the challenge of you need to look at the new technologies and validate them, and then you need to transfer that to routine analysis because that's what you ideally like. And there you're dealing with two different groups of people. The research scientists that will look at the different aspects of the instrument or the technology, and then routine people who have for the last 5 years maybe worked on one instrument or one technology, and then you need to carefully switch them over so they're proficient in the new technology. So that's a different kind of challenge to what universities face.
The full podcast will be available shortly, so check back soon.